Question 12, and this one's on exponential models. So it says the value V of a vintage car 2 years after it was first valued on the 1st of January 2001. I'm going to stop reading there. There's a key point in the question. So it was first valued 1st of January 2001. So T equals 0 when Jan 2001. Okay, it tells us the model then is V equals AP to the T, where A and P are constants. Given that the value of the car was 32,000 on the 1st of January 2005, again, another important piece of information, but actually, they're trying to catch us out here, because it tells us V equals 32,000, and you'd be forgiven for thinking that T was equal to 5 here, but T equals 0 is in 2001, so the T number is always one less than the A number, so here, we can see that T equals 4. And 50,000 in 2012, so that means that the value is 50,000 when T equals not 12 but 11. Okay, so the question then asks us to find P to 4 decimal places. So let's do it. So we've got the model. Which is V equals A times P to the power of T. And the first thing we're going to do is let T equal 4 and V equal 32,000 as per the information we gained from the question. So that means that the value 32,000 is equal to A P to the power of T, which was 4. So now letting T equal 11 and V equaling 50,000, this implies that 50,000 equals A P to the power of 11. So we've got two simultaneous equations here, which we're going to call A and B. So notice if we do B divided by A, we get 50,000 over 32,000 equals, well, the A's cancel to give P to the 11 divided by P over 4. Actually, let's show the A's cancelling. That would make a good exam answer, wouldn't it? Yeah, we shouldn't miss out steps of working. Okay, so 50,000 over 32,000 equals 25 over 16. So that implies 25 over 16 equals, and that cancels to P to the 7, which means that P is equal to the 7th root of 25 over 16 equals, and let's try and work that out. So the 7th root of 25 over 16 to 4 decimal places as asked is 1.0658. 1.0658 to 4 decimal places. And it's not enough to lose a mark, but we should use the approximately equal sign there because we're rounding. Right, so that's part 1. Part 2 asks us to show that A is approximately 24,800. So let's take equation A now. So this one here. So we've got 32,000 equals A times P, which was the 7th root of 25 over 16, all to the power of 4, which means that A equals 32,000 divided by, and this can be simplified, 25/16 to the power of 4 over 7. 25/16 to the power of 4/7, just for ease of writing it, which is equal to, so 32,000 divided by 25/16 the power of 4/7 equals 24796.8022. So let's rub that out. Approximately equal to, as we were asked to show, 24,800. Right, the next part, it asks us, with reference to the model, interpret the value of the constant A. Well, the model itself was V equals A, which we just found to be approximately 24,800, times P, which was 1.0658 to the power of T. So the value of the constant A, well, A happens when T equals 0. When T equals 0, this term disappears to give V equals 24,800. So A is the initial value of the car, i.e. when T equals 0. But keeping it in context, on 1st of January 2001, just to be completely safe. Part 2, the value of the constant P. Well, notice every time we add 1 to T, we times by an extra 1.0658. So P is the amount by which the value is multiplied each year. So this is telling us that increases by 6.58% each year. So next part, part C, to orient ourselves with the question, it said, using the model, find the year during which the value of the car first exceeds 100,000. So we've got this model here, and we want it to exceed 100,000. So let's write that down, 24,800 times 1.0658 to the power of T exceeds 100,000. Okay, so first of all, dividing by 24,800, we get 1.0658 to the power of T is greater than, then let's do this on the calculator. So 100,000 divided by 24,800 equals 125/31. And then we're going to log both sides, which implies that the log of 1.0658 to the power of T, now I've used natural log here, but any base logarithm will work. But I suggest whichever logarithm base you use, you keep the base greater than 1, because otherwise, if it's between 0 and 1, then you have to flip the sign, which causes problems. It's difficult to remember. So always, in my advice, keep the base of the logarithm bigger than 1. Okay, so natural log of 125/31. And another good reason to use natural logs is it requires fewer button pushes on the calculator, just a single button push for ln. Okay, now I can see that I can use the power rule here. I can bring that T to the front. So it implies that T log of 1.0658 is greater than log of 125/31. Let's make that look a little bit more like 125/31. So 125/31. Then divide by log of 1.0658. Now what we should do first of all, so you must remember that the log of any number bigger than 1 is also positive, but they could in these questions very well try and trick you and hide a negative number within a logarithm. So for example, log of 0.2 is negative. We should always check the numbers to see whether we're dividing by a negative and see whether we need to flip the sign. Now I know that this is going to be positive because it's the log of a number bigger than 1. However, it's always good just to check to get yourself in that habit. Okay, so we've got log of 125/31. Over 31 divided by our previous answer, which was log of 1.0658, which is 21.88. So T is greater than log of, and show every step, 125/31 over log of 1.0658, which implies T is bigger than 21.88, which means that if T has to be bigger than 21.88, find the year during which the value of the car first exceeds £100,000. Well, this here, 21.88, which we know is during the year 2022. Therefore, year is 2022. And that's that one done. For more videos like this, subscribe to our YouTube channel, and to find out more about our Skype tuition and revision courses, go to alevelmathsrevision.com.